Hi, I'm Tim Davis, DevOps Advocate with M0, and today we're going to talk about the pitfalls of infrastructure as code and how to avoid them. But first, I want to thank the conference organizers and sponsors for putting on the event, setting up a whole list of great speakers and great topics, and accepting me to be a part of it. This is my first time speaking here, and I think it's going to be a great one going forward. So let's kind of get into it. The sponsors, Cloud Labs, Microsoft, Techholic, the MVP program for organizing it. Thanks again. Definitely appreciate this. So about me, I'm currently the DevOps advocate for an infrastructure as code automation startup called M0. Previous to that, I was with VMware. I was part of a small group of people that created the cloud and developer advocacy team at VMware. Before that, I was on the networking and security business unit focusing on the NSX product line. Before that, I was an enterprise architect, and I was in infrastructure operations, systems administration. Long story short, my background is in operations and infrastructure. But really, the focus that entire time has always been on the app that's running on the infrastructure, because there is not really a point to delivering infrastructure just for the sake of infrastructure. You're delivering it for the sake of running the app that runs the business. So while I have been working with servers and operating systems and things like that, it's always been about the application and what's happening inside of that infrastructure. So let's kind of break it down from the beginning. What is infrastructure as code? It's exactly what you think it is. It's infrastructure built by code. Now, how did we get here? In the past, traditionally, you've just think of physical servers. Infrastructure folks, operations folks, systems administrators are all building these things, installing operating systems, deploying applications on there, configuring networking and switching, storage and all that, and just kind of building up an overall infrastructure that runs the app. With the advent of public cloud and things like that, it kind of shifted into a clicking around and saying, I need an EC2 instance and I want to run, this on it, click, 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 and do all this. It just, instead of physically building something, you're just clicking around and getting what you want. Developers at one point started deploying more and more infrastructure and kind of taking the initiative to build what they need. And developers don't necessarily want to click around in a graphical user interface to get what they want. They don't necessarily want to even go to a self-service portal and click around for a while. They want to package an API and shoot it off. They want to create a script that builds what they want. They want to do it in the tools and the languages that they normally speak, which is code. And that's really what brought the infrastructure as code model forward. So what types of pitfalls can come up when you're starting your infrastructure as code journey, when you're going forward with your infrastructure as code journey? I have some good and some bad news for you. It's both. It's all of the pitfalls that come along with infrastructure and all the pitfalls that come along with code. Now, for this, there seems to be a confusion or a misunderstanding that if a company goes off towards the infrastructure as code direction, that the infrastructure team is no longer necessary because they're just offloading that to the developers. And that's simply not the case. Developers, for the most part, aren't infrastructure savvy. They don't necessarily have that wealth of experience and that background in that. Just the same as most infrastructure folks don't have the wealth of experience and background in coding design and things like that. So it needs both of them to come together to really be successful quickly. You still need infrastructure, you still need developers, everybody kind of comes together. Now there's some companies where the infrastructure team is the one actually writing this code. There's some companies where the developers are actually writing that code. But as long as you have both of those teams that come together and work together, you can be successful quickly with that. It's really the development and operations kind of coming together, and that's, DevOps. So let's kind of break that down into a couple of different sections, and we'll start with some of the infrastructure pitfalls. All right. So the first thing here is going to be a question of what framework do you choose? We kind of talked about some of the things of infrastructure and operations kind of coming together. There are a bunch of different choices that you may need to make when bringing all these teams together. And it's, What cloud are you on? Let's start with that. So there's different types of frameworks that are cloud agnostic and that are cloud specific. For example, in AWS, you're going to be looking at CloudFormation. In Azure, you're looking at ARM templates. If you want to go cloud agnostic and say something that's either, about a multi-cloud framework, you may be looking at either a Terraform or a Pulumi or a TerraGrunt or something like that. And with those, they each have their own pros and cons. And I wish I could tell you, hey, go with this one. I can tell you that Terraform is pretty much the industry standard for community-supported infrastructure as code at this point. They support every major cloud provider you could want. There's modules for lots of different SaaS tooling that you may want to work with. And there's even some Terraform providers for like F5, which will allow you to work with hardware. So it all depends on what cloud you're using, how you're doing this. Do you want to be able to utilize multiple clouds? May you possibly migrate from one cloud to another? So if you're using CloudFormation and all of a sudden you have to start using Azure, those CloudFormation templates aren't going to migrate. Now, of course, Terraform stuff written for AWS isn't going to fully migrate either, but it'll give you a little better, starting point of where you're going to be. And you just change the providers around a little bit, make sure you got the right syntax and you're calling the right objects. But it allows you to work with multiple different clouds instead of just all in AWS. Now, I've also gotten the question, or somebody basically said, I know I'm never going to leave an AWS. Well, do you know for a fact your company's never going to be possibly acquired or bought out by somebody else who's in a different cloud? There's just, things that you may never know. But really choose whichever one works better for you. When we go to the multi-cloud frameworks, looking at Terraform versus Pulumi, there's a lot of developers that are going in the Pulumi direction these days, simply because with Pulumi, you don't have to learn a new language. Terraform uses a language called HCL that you have to, learn to write that out. With Pulumi, if you're writing your app in Go, all right, use Go. If you're using Node.js or what have you, it allows you to use the language that you're already writing in to write your infrastructure as code framework. So as you can see, there's lots of different, pros and cons and questions you need to ask, but really the very first step in your infrastructure as code journey is which framework you're going to be selecting. Security. This is a really, really big step here. Historically, security has been kind of an afterthought. Development has their own sandboxes, they're doing their own thing, and as soon as they're ready to turn that application over to production, that's when you start submitting all your firewall requests and getting things ready and then testing it out and all of that. Well, what if you were to say take security and shift it left in the development lifecycle so that every time you build your code and you run tests, you're doing all of your security tests at the same time. Things like Terrascan and Chekhov from Bridgecrew can help you go through and check your infrastructure as code files for, open S3 buckets that you may not want to have public, and other kinds of security misconfigurations that you can stop before they're actually deployed. And then, of course, there's compliance and other things. You may have rules where you can't deploy to a specific region, or you can only deploy to a specific region. Maybe in a specific application stack, you're only allowed up to 3 different instance types, or you're only allowed a certain instance size. With Open Policy Agent for policy as code, you can actually write your own checks so that every time you make that deployment, you can come through and say, okay, if it doesn't deploy to this specific region, cancel it. Or if it's larger than, this type of instance, cancel it. So it allows you to make sure that security and compliance are always checked every single time you do that deployment so that, you're not having to go back and fix it later. You're just fixing it right then and there, because taking 1 step back is better than taking 5 steps back. So we've talked about some infrastructure pitfalls. We've talked about, some of the choices that you can make and some of the issues that may come up with choosing specific frameworks, maybe if you're not including security. Also, at the very beginning, we kind of talked about how you really need to foster that communication between infrastructure and development to really, really be successful with this. Now, of course, there's always caveats. There's always, exceptions to the rule. But you will have a lot better time and a lot easier time with infrastructure as code if all of the necessary teams have a stake in the project and are available to answer questions, to help out. For instance, security needs to design security policy and stuff like that. So let's break into some of the coding side of the pitfalls here. So what are your default values? This is a big question you need to ask. If you're an infrastructure person and you're used to deploying out in your cloud and you need, say, a new resource or whatever, you go into AWS, you click EC2, you click to spin up a new instance, it's going to ask you a whole bunch of different questions, like what operating system do you want to use? What type of, IAM policy do you want to use? Do you want to peer this to a specific VPC? All of these specific questions are things that you need to answer. Now, there are some of them where you absolutely have to answer that question or it won't let you, deploy out. There are some of them where you don't have to fill in that value. It'll just give you a default value. When you're writing this infrastructure deployment as code, you have to be aware of this. You have to know, do I need to inject specific variables? Are there any defaults? And what happens when I leave that blank? So if you create your infrastructure as code files and you fill out all of the necessary specifications except for this one, like any specific security policies, what happens? Does the deployment fail? Does it insert a default value? You need to know this because when you're going through and designing your code and writing it, you need to make sure that you account for those specific variables so that you can know, do I need to inject this? Which ones am I allowed to inject? If it's blank, is it going to give me a default security policy that may be, not as strong as I want it to be? So that's all something that you have to kind of keep an eye out for. But there are ways that you can help mitigate issues with that and make sure that you're adhering to any kind of policy that you may need. And that's going to be Open Policy Agent. We talked about that just a little bit ago. And this can absolutely help you mitigate default value issues or incorrect variable issues or anything like that that may come along when you're creating and designing your infrastructure as code files. Because you can go through and say, every time we do a deploy, I'm going to run Open Policy Agent, and my policy is designed in such a way where it makes sure and validates that not only do I have specific values for specific things, but they are within the range of, it can be 1 to 3 instances, it can be within this region. So it really helps you enforce a policy so that you don't accidentally deploy something that you don't mean to. Dry. Don't repeat yourself. This is a development methodology that simply is trying to save you time. Why create 5 different copies of the same code for your different environments when you don't have to? So how do we mitigate dry issues? There's lots of different ways that you can go through and do this. There's lots of different framework choices and things like that. You can create variables inside of your files instead of hard coding your values. That way, every time you deploy, you can just change those values. There's a couple of different things that are purpose built to help you with dry code. Terraform modules is one of them. Instead of taking one giant piece of infrastructure as code that deploys a VPC, an RDS instance, an EC2 instance, and all of the different IAM policies and configurations all in one, you can break each one of those out to a reusable module. You store that module in a registry, and then every time you need to call it, it just pulls that code, injects the variables that you need, and it's off to the races. TerraGrunt was purpose-built to solve this exact problem. Now, Terraform also, will solve that problem natively these days, but back then, it didn't necessarily do that. TerraGrunt will allow you to take one sanitized copy of your infrastructure as code and then utilize that across all of your different regions and deployments and environments and just use little individual configuration files to customize that deployment so that you've got a dry set of code and then you've got a repeatable version there. Now, this allows you to be able to update your code one time every time you need to update it so that you don't have to go through and update 5, 6, 10, 20, however many versions of that code you have for each of those respective environments. Designing for state size. This is something that's very, very important. And we just talked about this a little bit, where you could go through and take all of your stuff and mash it into your infrastructure as code file, but maybe that's not necessarily the right choice. Now, why is that? It's actually going to be for performance reasons. You may be asking, what is state? when you do infrastructure as code and you create code files and you deploy it out, you need to have the ability to say what's deployed. Most of these frameworks are going to create a state file. And this is just going to be a snapshot, so to speak, of the active state of I deployed this type of resource with this configuration information. This is the IP. This is the load balancer URL or what have you. All of that stuff is stored into this little file. Now, whenever you update your code and you go to redeploy it, it's going to go through and check that state file for what's already there. And it's going to do that for efficiency purposes. So if, say, you've got 3 EC2 instances already deployed and you change that infrastructure as code configuration to be 4 instances, when your Terraform apply is running, it's going to go through and it's going to look and it's going to say, oh, I've already got 3 instances, so I just need to deploy 1. It's not going to go out and just deploy 4 because that's what it says. It knows I need to go from 3 to 4, so I just need 1. Now, if you've got all of your resources mashed into that one configuration file, even if you just update one little piece like an IAM policy or just a little bit of the VPC or just maybe an EC2 instance, it's going to have to go through and check and validate the state for every single one of those things. So how do we mitigate a state size performance issue that's going to cause our deployment times to go up? The good news is we've already learned that. It's going to be that don't repeat yourself methodology that we just talked about. So if you do break up your code into these Terraform modules, like you say you have your VPC and you have your EC2 modules and things like that, and then you have an automation platform that will allow you to say whenever your VPC is redeployed, it may automatically trigger one or the other if it needs it, or maybe not if it doesn't. That way, when you have a bunch of different state files for each one, whenever you go and do that redeploy, it doesn't have to look at all of your EC2 instances, all of your databases, all of your IAM policies, all of your everything. It just has to look at the VPC, or it just has to look at that. It'll make your deployment times go much farther up, and it'll give you a little bit easier management of all of your code. TerraGrunt, like we mentioned, it'll also kind of do that same thing, and it'll allow you to have a lot easier code management and break up all of your giant state files and pieces into much more manageable modules and states. So where to learn more? There's so much information out there on infrastructure as code, in automation platforms and things like that. If you have questions or anything for me, or you want to follow for more information, please feel free to hit me up on Twitter. That is by far the best place to get me. I've got email and all that kind of stuff, but I'm going to answer Twitter much likely before anything else. Hopefully this was helpful for you, whether you haven't started your infrastructure as code journey or whether maybe you're on the way, but there's just some stuff that you haven't thought of before. But feel free to let me know if you have any questions or anything like that, and enjoy the rest of the conference. And